Morning campers. Let's have a look. Okay, so the answer to this test, it was energy short assessment. Only about 26 marks, not a lot to do there. If you're at home, hope you have a go at it. Let's move on. Okay, very simple question to start with. Appliances show electrical transfer, different types of energy. Vacuum cleaner is designed to transfer from electrical to kinetic. 3 more are also designed to transfer electrical to kinetic. Which are the 3? It's going to be the drill, fan, the washing machine. Okay, circle each one. Okay, easy peasy. Which two of the following statements are true? Appliances only transfer part of the useful energy. Okay, that could be true. Energy transfer by appliances will be destroyed. That's rubbish. There are 2 more up here. The energy transferred. The energy transferred by appliances makes the surroundings warmer. That's correct. That's true. The energy output is bigger than the energy input. That's rubbish. Okay, and we've got to choose 2. So I'm choosing that one, and I'm choosing, that one. Okay, easy peasy. Good. Number 2. Washing machine washes dirty clothes and then spins the clothes to remove some of the water. Use the correct words to complete the sentence below. When the washing machine spins the clothes, something energy is transferred into, well, it's electrical, isn't it? We're putting electricity into a washing machine. It's transferred into useful. When we're spinning, it's kinetic energy. Okay. If it was heating up the water, it'd be thermal energy. Okay. Name one type of energy the washing machine wastes. Sound. Okay. I'm not sure whether you would waste a little bit of heat when it spins. Sound is the big one, and heat. Okay. What eventually happens to all wasted energy? The wasted energy is transferred into the clothes. Well, that's rubbish. My clothes aren't more energetic when they come out of the washing machine. The wasted energy is transferred to the surroundings. That looks reasonable. The wasted energy is trapped and reused. No. So it's that one. Okay. Okay, number B, part B, is we're comparing some values here. Look, now I apologise, it's split across the page, but we've got this that costs 260 quid, this is 270 pounds, this is about 250. That can wash this amount. This uses this amount of energy, and that uses, they use about the same amount of water. So the actual question is asking, what's the question asking? Use the information to give one advantage and one disadvantage of machine A compared to machine B. Now, machine A, advantage. Machine A, if you can see, look back, takes a bigger load. Okay. Another advantage could be it uses less energy, and it uses less water. Any one of those 3. Disadvantage, costs more. Another disadvantage, I think that's it, isn't it? Because it costs more. Machine A, let's have a look. Yeah, machine A definitely costs more. I think in terms of all the other ones, it uses less energy, look. It uses slightly less water. That's the only disadvantage. No, I'd shell out the extra 20 quid to buy that one. Yeah, because of the advantages. Good. Let's have a look. I've got some guys skateboarding. Awesome. It's a girl skateboarding on a semicircular ramp. Calculate the gravitational potential energy of the girl at the top of the ramp. Okay, and she's got a mass of 50 kilograms. Okay. Now, when she's at the top of the ramp, we're not interested in how far she's moved up that way. We're interested in how far she's moved vertically. Okay, it's distance vertically. It's interesting. So, our equation, GPE, I'll just write it as E, is equal to mgh 50 times. Now, they're using this value for G. That's a more precise value, more accurate value, 9.8, and we times it by the height, which is, now we're saying it's going to be 4 meters. So in reality, she's not actually going 4 meters because she's going from there to there. But I think in this question, we're just keeping it simple. We're saying she's going up 4 meters. And that gives us a gravitational energy of 1960 joules. Okay. A couple of marks there, one for working, one for that. Okay. The girl has a speed of 7 meters per second at the bottom. Calculate the kinetic energy at the bottom of the ramp. And we're given the formula, look. Easy peasy. You don't get this one. You should do. Right. Kinetic energy, EK, is a half mv squared, which is 0.5, times by her mass, which was 50, times by the speed, which was 7 squared. Do it on your calculator, and that should come out to be 1,225 joules. Okay. One for that, one for that. Not all the energy has been transferred. Which two statements explain why? Excuse me. Some energy is wasted. That's possibly. The mass of the girl is too low. That's rubbish. The ramp is not high enough. That's rubbish. The GP of the girl is not 0. The speed of the girl is too great. That's rubbish. Okay, so it's got to be some energy is wasted, and the GP of the girl is not 0. When she's at the bottom of the ramp there, she's actually a little bit higher there. Okay. Explain how lubricating the wheels means you can go faster. Reduces friction. Okay, that gets me one answer. Therefore, let's put this right now, less kinetic energy is transferred to thermal energy or heat energy. Okay, that's how it's losing when the wheel's spinning. There's your wheel spinning on an axle. Okay, when it's spinning round, there's a bit of friction there. So if you oil that, it spins much easier, and so you lose less energy to thermal energy. Okay, friction creates lots of thermal energy. Moving on. Gosh, what's this? Gas burner. We're given some percentages of energy transfer. Gosh, use the above information to complete the pie chart. Oh, someone's trying to contact me. So the surrounding air takes up 20%. 60% has been transferred to the water, 20% has been transferred to sound air, 13% has been transferred to the pan. So if that's surrounding air, that bit there represents 20%. And how many little squares are there? Little wedges, 1, 2, 3, 4. So each wedge is 5%, isn't it? Okay. So let's do the 60% to water. How many 5s go into 60? That's 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. All of that is going to be, that's going to be water. 13%, that's nearly 3 whole squares, I'd say about to there. As, let's make this a bit more shaded. 13% has gone to the pan. That's the pan, and that, therefore, that must be 7%. That 5 and a little bit makes 7, and that must be the gas burner. Okay. Ooh, that's quite tricky. A little bit of maths. Easy peasy. Some of the wasted energy, or rather, some of the energy is released. It's wasted. What happens to this wasted energy? It gets dissipated or spread out as heat. The 2 answers for that, 2 marks for that. So let's have a look. This is part 1. Okay, ideas. It's transferred to heat, dissipated, spread out, and it's also given to the surrounding air. is dissipated as heat into the air or the environment or the room. Okay. What percentage of the energy from the gas is wasted? Okay. All right. Now then, if 60% is useful because that's heating the water, then everything else is wasted. Okay. So 60% is good. So therefore 40% must be wasted. 1 mark for that. Easy peasy. Okay. Do a neat job of that if you ever encounter that sort of exam. I hope you enjoyed that. I will see you in a bit. Toodaloo.